The last day for homework is Sunday midnight, right? And that is Sunday the 12th, right? You still will be able to look at homework questions, but it won't change your grade anymore, okay? I would say get as much of the homework done as you can, and then just focus on the exam questions, right? The AM final exam, that's your final exam, right? I have a class at noon as well. So the AM final exam is 12:15, Wednesday 12:15, right? Does this sound correct? I said this already?
Yeah, at 8 a.m. Right?
Yeah, at 8 a.m. So that's a big change. So you're going to have to set an alarm or a double alarm, or maybe bribe people in the household to make sure you're up, and make sure they're quiet, just for 2 hours. Say, I'll cook dinner tonight, or I'll do the dishes tonight, or whatever, something, right? Just so you have a nice, peaceful place to take a test, your last test, right? Which is awesome, awesome, awesome. The other class takes their test Monday. Again, I'm thinking, what did I say, 10 to 15 problems? So even if I have 15, right, 120 minutes divided by those 15 problems, and I think I did this the other day, that's 8 minutes a problem. So 8 minutes a problem, that's plenty of time for you to show me that you finally know how to do something. And of course, one question might take 12 minutes and another one would take 4, and so you just got to be careful about being stuck on something. If you really are kind of blanking on something, it's good to move on, because something else might trigger what to do. It's good to, just really peruse your formula sheet. Maybe something will click there. You can always ask me a question, right? And so far in our reviewing, we have Robert's thoughts on problems. So far I said test 1, I liked, where did I put it? I wrote it down somewhere. I like 1, 3, difference quotients, 9 and 10. On test 2, I like 3, 4, and 5. There were only 5 questions on that test, but each one was like a double, right? And the first 2 were really review of test 1, right? Test 3, which we're going to be talking about today, and I might revise this. I like 2, 6, 8, 10. And then test 4, I'm saying anything but 9 and 10. I'm not going to put a real, most of you got 9 and 10 right, so there's no reason for me to put it on a final. You could say, well, put it on the final so I get something right, but no, I'm trying to give you a second chance, third chance to show me that you've got the other stuff. Okay. Any questions for me? Anything you're dying for me to cover before I jump into test 3? I think I did some of test 3 last time, did I? I kind of remember doing the exponential equation, but I didn't finish test 3, right? So anyway, all the tests are posted in Blackboard announcements, right? Everybody knows where to find them. The solutions are there, except for the solutions for test 1. The second half of test 1, right? I mean, we did so many problems like this, so it shouldn't be a big deal. And then the first part of test 1 was, I mean, you're just gonna do problems just like I did on Monday. Again, look at your notes too, if you want. That's probably the best thing. But sorry, announcements. So I want to look at test 3 today. Am I right?
Yeah.
Okay. So I am recording this. And I did record, like I said, I recorded Wednesday afternoon's session. If I do anything different this afternoon, I'll record that as well. So they're there. So if you look at number 1, it's a review of what we did in test 2. But in particular, if I give you one like this, I'll make sure that the function is 1-to-1. In test 2, when we graphed a rational function, it's possible to get something that's not 1-to-1, right? So, but I like this whole set of 1 through 4, right? And maybe I should definitely say that 1 through 4 will be on there from test 3. Where I give you a simple linear over linear, which most of the time will force it to be 1-to-1. That's a good question. Is it always 1-to-1? Yes. So linear over linear as a rational function, and then the same old questions, right? Okay. Show me it's 1-to-1 graphically. Prove that it's 1-to-1. Find the inverse. Prove that you have inverses. So that's a good set of 4 questions for you to be able to do on the final for test 3. Now you have my answers here, but does anybody want to possibly see any of that today? Hey, Grace is here, Alejandra's here, Diego, Vanessa, Eunice, Alan, Malcolm. Good morning, everybody. This is our last class meeting, except for our end of the semester party, which is your final exam. And it should be like a party, right? Should be a celebration of you saying, I got this now. I got this.
So we don't have class on Monday?
No, and that's true for all of your classes. The day of your final is the only day you meet, and that gives you more time to study for other classes. So if you have a Tuesday, Thursday class and you meet on Tuesday for your final, you don't meet on Thursday. Now there's an exception to this if you're taking a 7-week course in the second half. Then you have regular classes next week. And if that's the case and anything conflicts with your final, it shouldn't be with our class, right? Because there's no class starting before our class. So, but if you make sure you check that final exam schedule, make sure nothing is conflicting. Teachers are not allowed to move their finals, but if you have a 7-week course, it could conflict. So just double check that. Okay, nice. So number 5 is already on a previous test, but make sure you can do all of that, right? I sent Diego a bunch of extra practice problems on finding zeros and factoring. If anybody's interested in that, I can post that for you now, but I don't want you to get overwhelmed. Diego, did that page I sent you overwhelm you at all, or?
No, it helped. Thank you.
Okay, good. And you were able to do some of those already?
No, not yet.
Okay.
But I will.
Yeah, so that's what I'm worried about. Is like if I give you more practice, and I'm talking to everybody, you know, God forbid you try a problem and it just completely frustrates you, right? So you just want to be, and I try to be really careful on that, Diego. I think maybe the very last problem in 4.6, just be careful of that one. It's like a rational sine table 1, but it's greater than or equal to 1. And I didn't do any of those semesters, so just be careful of that. Your problem will be always greater than or equal to 0. Oh, actually, more likely greater than 0 because I'll put it inside of a log function like this. Right? So I like number 6. So I think we should start there for problems today. But maybe I'll give us a little. I'll do a different one, right? Yes, we okay?
Yes.
Nice. I don't like 7. I do like 8. 9 is too easy. And I like 10. Yep, so I got all those problems right that I want you to be able to do. So let's do number 6. Should I do the exact one or should I do a new one? Let's do a new one. This one, I'll make one a little bit easier for us than what will be on our test. So just give me a second here. F of x. Okay, here we go. So I'm doing one like test 3, number 6, right? So find the domain of f of x equals the ln of x squared minus 3x plus 2 over 2x squared plus 5x minus 3 using a sine table. Good. What's our main thing that we have to remember about the ln function? That's a knowing, knowing that ln of g of x implies what? The inside must be what?
Positive.
Yes. So I can't let it be 0 even, right? It must be a positive number. So I know that I must make a sine table. So we need, right, x squared minus 3x plus 2 over 2x squared plus 5x minus 3. Now the one I gave you on test 3 had a hole in it, right? And so there's not going to be a hole in the one because it gets a little tricky when there's a hole in the function. But you still do the sine table the same way. It's just usually that hole is not going to change anything. So So we want this to be greater than 0, right? And so what are we going to do?
We're gonna find the 0.
Nice. So we've got to factor and then
The
find
critical
and find the
values.
zeros, the critical values, exactly. So who's got the top? I think the top is pretty easy here. Yes, the domain. So we remember we have 3 rules for our functions for domain right now. Well, if you add in the trigs, there's more rules, but I don't think they're difficult. You cannot divide by 0. You cannot take an even root, usually for us a square root of a negative number, and the inputs of the domain, the argument of a log function must be greater than 0, right? So, those are our 3 rules that we're really going to carry on through the rest of
Is the numerator x minus 1, x minus 2?
Yes. So I need x minus 1, times x minus 2. And then downstairs, who can do that one? I can't do it by looking at it. So, and I don't like guess and check, but if you can just do it in your head, that's fine. But I can see an AC, right? I can see 2 times negative 3 is negative 6. And the factors of negative 6 are 1 and 6 or 2 and 3. And one of them has to be negative, right? So which of those add up to, what did I do wrong? Oh yeah, which of those add up to positive 5 is here, right? So I know I split the middle term, right? This is something that you learned in Math 50 if you took Math 50, or you learned it in Algebra 2 in high school. If you had a teacher that made you do guess and check, you should sue them for your money back. And so I get 2x minus 1 times x plus 3. So I'll call this thing g of x, right? And so what are my critical values now? And you're gonna use this concept of critical values all through Calc 1 and 2. Critical values of the function are where the numerator or denominator equals 0. Critical values of the first derivative are when the numerator equals 0 or the denominator equals 0, but of the first derivative. Critical values of the second derivative, same thing. So it's good that we see it once in pre-cal, because you're going to see it all through Calc 1 and Calc 2. So what are the critical values? Can you see the smallest one?
It's 1, 2, negative 3,
Good.
and a half.
Good. So negative 3, 1/2, 1, and 2. And I'm just trying to put them in order because I'm going to kind of create the number line with them, right? I've got a negative 3. I've got a 1/2. I've got a 1. And I have a 2. A little bunched up there, but that's not a big deal. In fact, let me put my negative 3 over a little bit, just to save some room here. Now, why am I putting open symbols on each of those? So I've drawn my number line like in second grade when you had a number line on your desk, right? And I've drawn holes in it, so I can imagine if I'm walking on the number line, I can't, if I step right on that negative 3, I'll fall through. I can't use it, right? Why can't I use the negative 3? Why can't the negative 3 be in my answer?
Because it's an ln.
Because it, well, yes, but because it makes my inside function undefined. I can't divide by 0, right? Why can't I use the 1 in my answer? Because it will make the interior function 0, and the domain of the ln can't be 0, right? So I also know that this thing goes all the way to positive infinity, and this goes all the way to negative infinity. And these pieces are creating the columns of my sine table, right? So the critical values and the ends of my domain create the column separators in my sine table. What creates the row separators?
The brackets, the factor.
The factors, exactly, the factors. So I've got an x minus 1 as a factor. I've got an x minus 2 as a factor. I've got a 2x minus 1 as a factor. I've got an x plus 3 as a factor. And the product or quotient of all of them in some specific design is the function g of x. How are we doing here? Thank you, Grace. Nice, Diego. Is this clearing things up, or just a good reminder, I would assume? I mean, what am I putting on my formula sheet? I'm putting the instructions, right? Factor it. Make sure the inside's bigger than 0. Factor it. Find the critical values. What the hell are critical values? Create a number line. Get the column separators. Get the row separators. What's next? What kind of values am I looking for?
In between values.
Yes. You remember what I called them?
No.
Test values. So in Calc 1, we're going to do something called a first derivative test. So you're testing those values in the first derivative. We're going to do something called a second derivative test. So you're testing values in the second derivative. This one is the test value of the function, of the original function. I need values left of, right of, and in between all my criticals. So I like negative 4. I like a 0. I like a 3/4, 0.75. I like 1.5, right? What is that? 1.5 is 3/2, and I like a 3. You can use decimals, it's fine. In fact, if you graph this thing, you don't have to really think about this at all. I'll show you how I learned to cheat in pre-calculus. So in my calculator, I'm putting in my function g of x, right? I want to put in standard form, right? In calculator, y1 equals standard form, not factored, right? But my whole numerator and denominator are wrapped because there's multi-terms. Yes, you with me? Not wrapped like a Christmas present or like a Marshall Mathers? Who's Eminem? How do you say his name again? His real name. Because I can see where all my criticals are, it's not that necessary for me to worry really about a zoom. Zoom standard would be fine. You could see that I would get a little bit better view if I narrowed the window a little bit, right? Because I only have to go as low as -3. So I can change my window, but you don't have to, right? but it looks like, and I can't quite see too much here, but I do know that there is a vertical asymptote at -3 and 1/2, right? And there's a horizontal asymptote where? Where's my horizontal asymptote?
One.
Nope.
Two.
Nope.
I don't know.
Y equals a half?
Yes, 1/2, right? Because I've got an x squared over 2x squared, right? You see that? You see the x squared over 2x squared?
Oh, yeah.
So I'm seeing, I'm having a little trouble at my 1/2, but I'm gonna let my sine table do the rest of the work for me. I've definitely got something up here, but I don't know what else it's doing yet for my graph. So I'm gonna let the sine table figure it out for me, right? I don't know what's happening at 2. Okay, so I already know when I test -4, what? When I test -4, what am I going to get out of this sine table? Where's my function? Above the x-axis or below the x-axis?
Below.
Below. So the function?
A negative.
It's positive. Isn't the function up above the x-axis? At -4, that's what I'm plugging in, right? What am I going to get out of the function? A positive.
Oh, yeah. All
Yes.
negatives.
I don't know. I'll put that in a second. Most likely all negatives. You're right. I didn't think that's what you were saying, but I agree. This one's negative. This one's negative. This one's yes, all negatives. So a product or quotient of 4 negatives will give me a positive. What did I choose to check? My next function, my test value is 0, and look at where I'm going to be. Right? Look at where I'm going to be. I'm going to be negative on the whole function. I'm going to be below the x-axis. Right? When I plug the 0 in, I get a -1, a -2, a -1, and a +3. So an odd number of negatives. Right? I get a negative, a negative, a negative, a positive. Again, I don't care about the numbers. I just care about the signs, the SIGNs. Right? So I get a negative there. The next one I have to check is 3/4, right? I'm sorry. Yeah. And I can already see where's my function going to be there. Oh, no. I don't know. I got to plug it in. This is where I'm confused. So 3/4 is what? 0.75, right? So negative, positive, positive. So that's positive there. So that's above ground there. I get it now. So that little piece between those two sections is above ground. Now you're saying, well, wait a minute. How can the function cross a horizontal asymptote? It can in the short run, not in the long run, right? Function can cross a horizontal asymptote near the origin, or not all the way at the end. All the way at the end, it gets closer and closer to it. What happens when I plug in 3/2? What is that? 1.5, positive, negative, positive, positive. So negative there. So I'm underground here. I can't quite see it in my picture, but I got to be coming underground here. and then now we're testing right at 2. Is this okay with everybody? So positive,
Yes.
positive, positive, positive. I'm back above ground again. So doing something like that. It's just really hard to see it on the graph. On the calculator. If I did it on Desmos, easy. So you're kind of cheating and doing the sine table, and it should help you out. So what are the intervals I need? Right here, I need all these positive ones, right? So the domain of the ln of g of x is from minus infinity to -3. And I'm not using my test values in my interval. I'm using the criticals. 1/2 to 1 union 2 to infinity.
Professor,
Yes, Grace.
when should you use the square brackets?
Well, in this particular one, because I'm not allowed 0, even in the numerator, I'm not allowed 0 in the denominator because I'm dividing by 0. I'm not allowed 0 in the numerator because then I'm taking the ln of 0, and that can't happen. So in this particular one, I never use the square brackets. Nice. So I think we did number 8 last time, am I right? Would you like me to do another one like 8?
Yes, please.
Sure. Let me just make sure I have a decent problem here. I'm pretty sure I do. So this is another one like 8. So this is test 3, number 8. I have 3 to the 5x minus 2 equals 2 to the 6x. And I want to solve for x a couple of ways, right? I want to solve using an ln. I want to solve using a single log with the change of base formula, and I want to get a decimal approximation. And I'll show you even how to get that decimal on the calculator today, right? So what do we do both sides?
ln.
Yep, ln. What allows me to do that?
Is it because it's 1-to-1?
Exactly. So I know I'm going to keep the equality. If I put equal inputs in, right, I know I'm still going to get the same value out because of this one-to-oneness, right? So now my properties of logs, I get 5x minus 2 times the ln of 3, and I get 6x times the ln of 2. I mean, if you could see it, and let me know if this bothers you, I could just bring the x out and leave the 6 in, because I know I'm going to put it back anyway, right? After I factor out the x, I'm going to put that coefficient of 6 back onto the 2. Is that okay if I do that, or you want me to keep it as I've been doing it in the past? Does it bother anyone?
For me, it's fine.
Anyone bothered by it? And I do have the chat open. So if you want to say it bothered, yeah, I don't like that, and I won't say who says they don't like it. Good. That's good that you can handle that. It's good. I'm going to distribute. Uh, 2 to the 6 is what, 64? Yep. I want to get all of my x terms on one side, and I want to try and minimize the number of negatives. It looks like I can move my x term to the left and my 2 ln of 3 to the right. And so I still keep only one negative, which is good. If I went to the other side, I'd have 2 negatives and 1 positive. It's not wrong. It's just easier to deal with algebraically this way. I want to throw that 5 back in. Uh, 2 ln of 3 is what? Ln of what? 2 times the ln of 3 is what? Good.
ln 9.
Yes. Factor out the x. Uh, 3 to the 5th is, I forget, 243. So I get x equals the ln of 9 over the ln of 243 divided by 64, right? I don't think that reduces. No, does not reduce, right? So there is my answer in terms of ln's. What can I do for change of base formula?
The log way.
Log of 243 over 64 of what? Log base 243 over 64 of 9. And I like the first one to get me an approximation, right? Ln of 9, close paren, divided by ln of 243 divided by 64. So I get approximately 1.646874693, or approximately 1.65. When I was in college, I had a calculator that would give me like 20 decimals. But I put like the 17th decimal place wrong just to see if the teacher would catch it. You want to see the solution found on the calculator so you can make sure you're right? No? Okay. The last one on test 3 is graphing that, right? Graphing that kind of trig function, getting the quarter steps and getting a quarter step, finding the starting point, finding the other steps, and then giving a nice graph of it. So let's do one like that, right? And then if you don't have any more questions for me, I guess we're done. But if there's something you want me to do, make sure you have it ready for me, okay?
I think we can be ready for Wednesday.
All right, let me just make up a new one for number 10 here. So let's do y equals, sorry, 3 times the cosine of 2x minus pi over don't tell me. Yeah, pi over 3. That's enough. I don't have to do anything else. I'm just trying to let you show me you can do it now, right? So what's the amplitude?
Three.
Good. What is the frequency?
Is frequency the same as period?
No.
Pi over 6.
No.
It's,
Two?
2.
pi over
2. Frequency is 2. Right? Remember, we're going to always factor, we're going to always factor this inside. So I take out a 2, and I get what? X minus pi over 6. Right? If you factor out a 2 from the numerator, you've got to double the denominator. That's the easiest way to think of it. But of course, if you distribute it back in, you'll see it works, right? So the frequency is 2. What does the frequency tell me? How fast the point's moving around a circle, right? Or how many times the cosine curve is drawn inside of 2 pi. Now we ask, what's the period?
Pi.
Yes, 2 pi over 2, right? We're going to do the 2 pi over the period. And what's a quarter step?
Is it 2 pi over 3?
It's take the period and divide by 4. So a quarter step is, right, me cutting it into 4 quarters, the quadrants. So take the period, cut it into 4. Where do I start? Where am I going to start my cosine curve?
At pi over 6.
Nice. When I take that first step, and you can see the cosine curve, right? When I take that first quarter step, where do I end up? Yes, a height is 0, but I want to see where that first step ends. So I'm going to do pi over 6 plus the quarter step, right? Start plus quarter step. And it looks like, what do I get? I can use a pi over 12, right? So I need a 2 there and a 3 there, so 5 pi over 12. Yes, we agree? Nice, Grace, thank you.
How do you get that pi over 6 on the start?
It's that horizontal shift, right? Right there. So what makes that back at the origin?
Okay.
Right. Now, what do I want to do with the pi over 6? I want to write it as something over 12. And obviously, that's 2 pi over 6, right? Sorry, 2 pi over 12. Yes? Why? Because that tells me now how much I have to add to get to the next step, right? So from 2 pi over 12 to 5 pi over 12, I added 3 pi over 12. Or better yet, just think of the 3, adding 3. So now here is starting steps. I started at 2 pi over 12. Then I went to 5 pi over 12. What's next?
8 pi over 12.
Nice. It's that easy. 11 pi over 12. And finally end at 14 pi over 12. And I guess I should do that as brackets, but it doesn't matter. So now I'm ready to draw, right? So I know I'm starting at positive 2 pi over 12, but I want to write out my scale in pi over 12s. It would be nice if I could only have evens, but I can't. I have 2, 5, 8, 11, 14, right? So I basically need them all. 1 pi over 12, 2 pi over 12, 3, 4, 5 pi over 12, 6, 7, 8 pi over 12, 9, 10, 11 pi over 12, 12, 13, 14 pi over 12. So you can see I'm creating that kind of outer piece of that rectangle that I'm always trying to draw, right? And that rectangle should go up to what height? Up to 3 and down to -3, right? And these pieces are giving me my quarter steps. But I know what cosine looks like, right? It's the smile one. And it'd be nice if you labeled things too, right? But this is the x-axis, this is the y-axis, this is y equals 3 times the cos of 2x minus pi over 3. And I guess I should label my tick marks. And I don't expect you to reduce these things. My curve is not perfect, I guess, but neither am I. And of course we know it keeps going, right? Nice. So let me check my chapter. Let me check my question list again. Just make sure it looks good. So from test 3, 1 to 4, 6, 8, 10, yes. The other ones, the ones I'm skipping on those is because they've already existed on another test, right? So it doesn't mean you shouldn't do them again. Like if I'm looking at test 3 and I'm looking at number 11, should you do that one again? Is that one a possibility for the test?
Which one, 10 or
11. Well, I just did 10, so yes. But look at 11. Yeah.
Yes.
It's from the first test.
It's a difference.
Right. So why did I put it on test 3? Because I have students who couldn't do it on test 1 or 2. So, but when you're looking over your test, just because I said do last one on this test I said was 10, look for ones that are similar to other problems and make sure you do them, right? And you have all the solutions. And you can email me. Like if you said to me, here was my question on test 1, send me a picture of it. Can you give me a solution? I'll say yes. I'll write it down, take a picture, send it to you.
Professor?
Yes, Grace.
I'm sorry, but could you go back to the drawing
Yes.
of the cost curve?
Yes. Oops.
Thank you.
You're welcome.
So when we said that the frequency was 2, how is that implied onto the
Nice.
drawing?
Nice. So notice that 14 pi over 2 minus 2 pi over 2, sorry, over 12, is 12 pi over 12, right? Which is pi. Okay, that's the period. But we know the cosine normally fits inside of 2 pi. Right?
Oh.
So what you can see is that inside of our normal period, right? Inside of our normal period, I've got the curve sketched twice. The interesting way to think about this is that you can imagine, or at least I can, because I love music, that I've got one point moving around the circle at a speed of 1 and the other point moving around the circle at a speed of 2. So I want to animate this point at a speed of 1. Stop. I want to animate this point at a speed of 2. Stop. So let me move them close to the beginning again. And I'll say, I'll just make this guy different color, orange. Blue. And so the orange point is me doing the original cosine curve or sine curve. And the blue point is me doing the one at a frequency of 2. And so watch what happens. Oops. What happened? Target all motions. Okay, I don't know what I'm doing. What happened? Let me try this. Edit, action button, animation, counterclockwise, okay, now I want to check my speed of 1. Oops. Sorry. And check my speed of 2. Here we go. Okay, so remember, the orange is the original curve, the blue is with the frequency of 2. And so watch what happens. So the orange is moving around and graphing over 2 pi. Now watch what blue is going to do. Blue is moving twice as fast. It's going to catch orange right at the same time, right? So the blue moved around twice, made the curve twice, in the same time that orange made the curve once. Now this to me is music, where orange is I'm playing a single string, and blue I'm playing the octave. So if you can imagine me plucking a string of a violin and you can see the wave in it, if I put my finger on the octave, the 12th fret, or cut the string in half, and pluck it again, the string is moving twice as fast. Well, what should we look at? Any requests? You feeling good about this test? Yes? No? Opinions? Don't give up on me. Don't Don't give up on yourself. Yes.
I think I did do it.
Yes. That's the way. We want to be thinking positive about this. You're about to go on stage and perform in front of thousands of people. I mean, you've practiced and practiced and practiced. And now you get to show off, right? That's what a test should feel like. Yes, you wanted to quit a couple of times during, at least once, right? But you can do it. All right, I had a request for short run, long run behavior. What's a quick way of thinking of long run? This is my horizontal asymptote, right? What's the quick way of thinking of short run? Does it look like y equals 1 over x? Or y equals 1 over x squared? Right? It's going to look like one or the other, plus or minus, right? So, for example, if I have f of x equals x minus 1 over x squared minus 4, that's my standard version. What's the factored version? X minus 1 over x plus 2x minus 1. Where are my horizontal asymptote? What is my horizontal asymptote? Y equals what?
One.
So it's x over x squared, which is 1 over x. And remember, x goes to 0. As x goes to plus or minus infinity, what happens to 1 over x?
It approaches 0.
Nice. So there's my horizontal asymptote. Remember, we said when the denominator dominates, the horizontal asymptote is y equals 0, right? Where are my vertical asymptotes?
X negative equals negative 2.
Plus or minus?
X equals
Yeah, plus or minus 2, exactly. So I already got a pretty good picture of this curve. Here's my x-axis, my y-axis. I know at 0 there's a horizontal asymptote. So as my curve moves to the right, it's going to get closer to 0, right? As x goes to the right, it's going to get closer to 0. I don't know above or below. And as x goes to the left, my curve is going to get closer to 0, right? And then at plus or minus 2, 2, I've got vertical asymptotes. Now, I can find points here, and on your test, I will ask you to find some points, intercepts, things like that. But I really just want to look at the short run. So for short run, I have to do the short run at each of these pieces in the domain that make the downstairs 0. So short run at 2 is f of 2. Well, that's 2 minus 1 over 2 plus 2 times x minus 2. Why can't I put it into the x minus 2 piece? Because
it's going to be 0, right?
Exactly. So I get 1/4 of the curve 1 over x minus 2. So I'm really thinking of a 1 over x feel there. So it's going to do something like this, right? At 2, I should see really close to 2, I should see that shape of 1 over x, right? Now, let's do the short run at minus 2. Well, again, I can put it upstairs, but I can't put it into x plus 2, right? But I can put it into x minus 2. So it looks like I get 3/4 times 1 over x plus 2. So again, it looks like 1 over x. So it's got to do something like this. It's got to be above on the right and down on the left. Right? Do you see the two 1 over x curves? There's a 1 over x curve, right? So you can kind of superimpose them at my new kind of origin of blue-green, right? So where it crosses blue-green, I see the 1 over x curve. Where it crosses at blue-green, I see that 1 over x curve. And then all I have to do is figure out how to connect, right? And that's easiest when I find points. So, but again, you're right. You're asking me for short run, long run. It's it. That's simple, really. And the best part is you can cheat on your calculator, right? You can put it on your calculator and see it instantly. And you can almost fake your understanding until it clicks, right? So my y equal is, I forget already, x minus 1? Yeah, parenthesis x minus 1, close parenthesis, divided by open parenthesis, x squared. Remember, when I put them in, I want to use standard form. And I want to just graph. It's my calculator always resets. So but you can see exactly what I have, and then just where it's connecting there is our only real question, but that's not difficult, right? So where is it connecting? The y-intercept is 1/4, and the x-intercept is 1. So it's doing that. Good. Alejandro, thanks for asking that. That's good. How do you feel about it now?
I'm still gonna practice a bit more, but
Good.
I understand it more.
Good,
Yeah.
good. And what are you going to put on your formula sheet? The explanation of how to find it, right? You got to put some step by steps. I took a lot of time. I'm talking to everybody. When I give you a process, the process step by step is very, very, very simple. But the whole thing is quite complicated. It's like brushing your teeth, right? So put the process down. If that's what you're having a hard time remembering, put the process down. Write small, right? I'm psyched to see what you all do on Wednesday. I am. What else? Nice. We're all done.